I, I'm going to go over questions from Math 85 Practice Final. So I'm just going to touch on a couple of things. I don't know if I'll get through the entire thing today, but I am going to work on just a few problems to give you an idea of how some of these are solved. So we're just going to go through this. All right, so the first one, it says you want to just complete the tables. Just check off which number these will be. So again, the square root of negative 2 is the same as I times the square root of 2, and that's considered an imaginary number. And by default, it is also a complex, because again, the complex number system contains all of the imaginary numbers. Imaginary numbers are of this form, of this type. It's not real, and therefore it's not anything else. Second, we have a complex number that has both a real part and an imaginary part, and so therefore it is a complex number. It is not an imaginary number, though. 6.2, it would be considered complex, real. It's rational because it's a terminating decimal, and it is not an integer because it's not a whole number. It has parts. It's 6 and 2/10, or 6 and 1/5, and so therefore it's not an integer, and it would not be a whole number. Again, complex number contains all of the reals and all of the imaginary numbers and all of the complex numbers. And so all of these numbers that we'll deal with are complex. Is it imaginary? No, it does not have an I associated. Is it real? Of course it's real. It is not irrational, but it is rational. And it's not an integer or a whole because it is a fraction. Fractions are decimals, and therefore they are part of a whole. In order to be an integer, you have to be a positive or negative whole number. So we can't check any of these. Now, it turns out the square root of 81, let's move on. The square root of 81 is equal to 9. 9 is complex. It's not imaginary. It is real, it's rational, it's an integer, and it's a whole number. Pi is complex, of course. It is a real number, and it's actually an irrational number. It cannot be expressed as a fraction with integer numerator denominator. Therefore, it is not a rational number. So this is the solution to the table. Be sure to submit comments if you have questions when watching this video. Let's move on. Now, in order to add these two, they have to be like terms. And so I have to reduce the square root of 28 to 4 times 7, and then plus root 7. Now, it turns out that this can be written as 2 root 7, and then plus 7. It gives me 3 root 7. And so there's the final answer there. And again, same type of problem. Right now, they are not like terms. And so it turns out 98 can be written as 49 times 2, b to the 7th. And this one can be 18 can be written as 9 times 2, b to the 7th. And so we get 7 root 2 b to the 7th and 3 root. And now we can add them together. That's 10 root 2b to the 7th. Now, we can simplify this a little bit further. B to the 7th can be written as b to the 6th times b, which is just 10. Now, let's take the square root of b to the 6th out. The square root of b to the 6th is b cubed, so it comes out. And our final answer is just 2b that time. Let's do a few more. Number 4. We actually have to distribute this property here. So we get the square root of 6 plus the square root of 12. And can we simplify this? No, we cannot. 12 simplifies. The square root is 6 days, but 12 simplifies to 2 root 3. And that's the final answer. We cannot do anything else with that. Now, we have to simplify this expression, and so we have to get rid of the radical of the denominator. That process is called rationalizing the denominator. So what we have to do is multiply the top and bottom by the conjugate of the denominator. And again, the conjugate of the denominator, just the conjugate of root x plus 8 is root x minus 8. And now just distribute. So we get up top, we get 5 root x minus 40. And then on the bottom, you actually have to multiply this out. You have to FOIL it out. We're going to end up with just x minus 64. And we can't do anything else with that. That's the final answer. All right, let's move on. Now, again, in order to solve radicals, you must isolate that radical first. So I'm going to add 3 to both sides. When you do that, you get 9. And now take the square of both sides. To get rid of that radical, now that it's isolated, we can just square both sides. And then we'll square this side as well. So we're left with just 2x plus 1 equals 81. When you subtract 1, you get 2x equals 80. Subtract 1 from both sides. And then finally, we get x equals just 40. Divide both sides by 2. Let's move on. Number 7, multiply. And we're basically multiplying 2 monomials together. We're going to get negative 18. Multiply the numbers. And then when you multiply exponents, you add the power. So x squared times x is x cubed. And y is there. That's the only term. Let's move on. Evaluate. We have to evaluate this according to the order of operations. It's parentheses, exponents, multiplication, division, addition, subtraction. Now, there are no parentheses, so we move to exponents. So we can simplify this exponent. And now we multiply or divide from left to right. And so that's going to be negative 16 divided by positive 2 is negative 8. And then times 3. Now we multiply again. 5 minus 24. And then finally we get negative 9 for your final answer. Find 10% of 10. That is the same as finding 0.10 times 10. 0.10 times 10 is 1. Okay, this expression, they do not have the same denominator, so we have to make them have the same denominator. This one needs a factor of x plus 6. This one needs a factor of x minus 8. So what we have to do is multiply x plus 6 to the first part. And to our second part, this part, you have to multiply the top and bottom by x minus 8. So now what do we get up top? X plus 6 times x plus 2. Let's multiply 2 binomials. The middle term is going to be 9x. The last term is going to be 18. So we get x squared plus 9x plus 18 up top. On the bottom, we still get the same. We don't have to multiply it together just yet. Minus, what do we get up top here? X plus 1 times x minus 2, we know the first term is going to be x squared minus 7x minus 8. And then again on the bottom we get. Now that the denominators are the same, we can combine like terms, okay? And when we do that, we're going to create one group and distribute that minus sign. So we're going to be left with x squared plus 9x plus 18 minus x squared plus 7x plus 8. And it's all over x plus 6 times x minus 8. And now just simplify that top part. And there are some things that will cancel out. The x squareds cancel very nicely for us. And we're left with 9x plus 7x, 16x, positive 18 plus 8, 26. And then it's all over x plus 6 times x minus 8. It doesn't appear to simplify any further than that. Okay, in this particular problem, it says solve and check. So I guess we have a fraction, and the LCD would be 30y. And so the best way to probably do this is to multiply each term by 30y. So that's going to be both sides of my equation by 30y. And when you do that, you have to distribute that 30y in there. We're going to be left with 6y times 3 plus 30 times 7. My y's cancel. My 5's cancel here. I'm left with 25y. I need to simplify this. This is 18y plus 210 equals 25y. Now when I subtract 15 for both sides, I'm left with 210 is equal to 7y. So y is 30. And you have to check that. Does that equal 5, 6? And yes, we do. We do get 5, 6. Multiply the top and bottom by 6 here. We get 18 over 30 plus 7 over 30. 25 over 30 is equal to 5, 6. So check. 12. Now, we have two rational expressions set equal to each other, so we can cross multiply. Distribute. Add 240, 280 to both sides. Subtract. Now divide both sides by 32. And so it goes in there once and make that twice. So you get x equals 12. And to check that, you can just plug 12 back into the original problem for x. X instead of x plus 13, you do 12 plus 13. And then just do 12 minus 7. And of course, 40 over 25 is the same as 8 over 5. So it does check out. What percent is 50 of 40? And so that's actually going to be more than, it'll be more than 100%. 50 out of 40 is more than one whole. So if you reduce this number, we get 5/4, which reduces to 1.25. And then when we change that into a percentage, we get 1.25%. So how many yens is $12 if 80 yens is equal to $1? So we have dollars, we need yens. So when we multiply this out, well, 12 times 8 is 96. So 12 times 80, 960 units. Okay, let's do a few more. 3, 9, 5, and 15. What would be the LCD between those two numbers? Those numbers. Between 3, 9, 5, and 15. Turns out 45 goes into all of those numbers. So if we could multiply both sides by 45, we multiply both sides by 45, we can reduce this problem a great deal. 45 divided by a third is 15x, plus 45 times 2x, we get 10. 45 divided by 4/5 times 45 will give us 9 times 5 is 36x. And then finally, 15 divided by 45 is 3. And so when we collect our signs, subtract 15x on both sides, add 3 to both sides, we're going to be left with 13 is equal to 21x. When we divide, we're just left with 13 over 26. Okay, here we go. Solve. Distribute your minus sign. Drop the parentheses. Distribute your 3. And what's 44 times 3? 132. Combine like terms. We got 17x minus 12 is equal to 15x plus 132. Add to both sides and subtract as well. We're going to be left with just 2x equals 144. So x is 72. Solve and show solution on a number line. So what we need to do is actually solve for this variable. I'm going to simplify that the right-hand side. Distribute the negative 2. Subtract 24 from both sides. We're going to be left with negative 6 is greater than negative 2x. Divide both sides by negative 2. When you divide an inequality by a negative number or multiply by a negative number, the sign must change direction. So we're left with x is greater than or equal to positive 3. And on a number line, if this is 0, we got 1, 2, 3, 4. So we're going to start at 3, a solid dot at 3, and everything greater. That's all the x values. Graph the inequality. You could graph this inequality by graphing its intercepts. If you look, it's kind of in standard form. So if I let y be 0, x is 6. And then if I let x be 0, y would be 3. And it's a solid dot because of my inequality. And now all I have to do is test the point to see if it's true. I'm going to test the origin. Plug in 0 for x and 0 for y and see if the inequality is true. It is true. And since the origin is true, all values on this side is true. And this would be a solution to the inequality. Okay, I am going to do one more example and then we'll take a break and come back and do part two. So this will serve as part one. We have another example, graph the inequality. So right now the inequality is not in slope-intercept form, nor is it in standard form. So what I'm going to do is add 2y to both sides. I'm going to put it in standard form. I get 3x plus 2y. And if I just switch it around, that's the same as saying 3x plus 2y is less than 12. Now I can graph this by its intercepts. If I let x be 0, y would be 6. If I let y be 0, x would be 4. Because it's a strict inequality symbol, I must put in a dotted line. And now I have to test the point. I'm going to test the origin at 0, 0, and see if it's true. If I plug 0 in for x and 0 in for y, I get 12 is less than 0 plus 0. That's clearly correct. It is true. And because it's true, now I get to shade all values that's on the side of my test point. I hope you enjoyed this quick review of the practice final exam. I'll be looking for questions, and if you have any comments or anything that you want more clarity on, reach out to me and I will be in touch. Take it easy.